Hello, everyone. Welcome to this Telops webinar. We'll give a minute or so to let other people arrive in the webinar platform. So while waiting, I'll just say thank you for everyone for attending. Good morning, good afternoon, good evening, depending where you are. It is 5 a.m. here in Quebec City in Canada. So I know some people will be in Europe, so 10 or 11 a.m. We'll be joined with the team from Joowon in South Korea, where it is 6 p.m. today. So pretty broad coverage for the time zone here. Okay, I see a few people coming in. Great, so why don't we get started? I know more people will probably be joining as we start. So before we get started, we always like to do a little poll to understand our audience, what kind of background you have, what kind of experience you have with IR imaging. So I'll set it up and you'll see it appearing on your screen, and you'll be able to click on your preferred answer. So let me just get this started. So here we are. Okay, just asking, how would you rate your knowledge of infrared imaging technology? So either you have no direct experience, but you're interested, you've considered it, you have some direct experience with it, either collecting or processing the data in some way, or even considering yourself somewhat of a thermal imaging expert. Okay, great. So thank you for answering. We have a good distribution here. Quite a few people having some direct experience with IR imaging, so that's great. We welcome any kind of questions. There is no dumb question during a webinar, so feel free to use the platform. So you'll see a question tab on the window of the webinar to go to webinar platform. So write in the questions. You don't have to wait for the end of the webinar to ask your question. So just write it down, and at the end, we'll go over all the questions and answer as best as we can. Great, so welcome everyone. Oh, let me take away that poll. Here we are. Welcome everyone. Quick introduction. So my name is Antoine Dumont. I'm a field application scientist for Telops. And so today we'll be talking about train inspection with IR imaging, and we'll be joined by experts on the topic. So Joowon and Christian will be our main speaker, and we'll be joined by Mr. Kim as well from Joowon. So I'll just introduce Telops briefly at the beginning, talking about our product line, giving a few examples of the IR data that can be collected. And then I'll pass the baton to Christian to be our main presenter today to talk about train inspection and what kind of system they've developed at in South Korea at Joowon. We'll finish, like I mentioned, with questions and answer. So first of all, Telops, we were founded in 2000 in Quebec City, and we are still based in Quebec City, Canada. We employ now more than 100 people with different advanced degree, PhDs, masters, engineering, a lot of engineering people at Telops. We're really proud to have established ourselves as world leaders for thermal imaging. There's a big focus on R&D at Telops, always pushing the development of the technology. And we joined, we joined Exosens in 2023, a larger umbrella company that's really trying to cover the whole electromagnetic spectrum. So it really fosters the growth of every technology in that area, and a collaboration for technology that covers different bands within that spectrum. We offer a whole suite of infrared cameras, instruments, and we offer different kind of solution, hyperspectral, multispectral, and broadband cameras, even for the detection and quantification of some methane leaks. So we have a whole service dedicated specifically to that now. So here's our line of products as a broad overview. There's quite a few products even within each category. We started first with hyperspectral cameras a while ago. 20 years ago, we had hyperspectral cameras only. And we still have really strong products in that category. Our hyperspectral cameras that we see here is the Mini XLW or mid-wave fast camera. It's a very powerful system. Not necessarily the best system for train inspection, so I won't spend too much time on this today, but we're talking about an infrared detector combined with an interferometer in front of it to create a spectrally resolved infrared image, so creating data cubes. In between a broadband and a hyperspectral camera, we have multispectral cameras where we have 8 filters rotating quite fast, so we can have a simultaneous acquisition with 8 different filters, either neutral density filters, or a just spectral filter, yes. So for faster acquisitions compared to hyperspectral systems, but a lower spectral resolution, then that's something that could be interesting. And now we reach the broadband camera range. We have a new high dynamic range camera, the HDR M700, which is really revolutionizing IR imaging capabilities nowadays. If you're interested in that topic, there's a recent webinar specifically on this camera with the amazing capabilities that it has. But for today's topic, we're more in the realm of the high performance fast cameras, so the scientific accurate camera with a cooled system, either the high performance one or the entry level radio camera system. So just to give a few examples of the kind of applications that we cover, you can see quite a few here. I won't go into details. We'll talk mainly about terrain inspection today. But there's ballistic combustion, IR signature, which is broad field, just covering any kind of thermal signature that can be detected with cameras. Gas detection, more in the realm of hyperspectral imaging, sometimes multispectral imaging as well. We have cold spray and experimental mechanics, additive manufacturing. Non-destructive testing, that's slightly more in the direction of terrain inspection, where you're able to inspect, monitor thermal temperature increase or defects within some materials using IR cameras. So this is what we're trying to accomplish with infrared cameras with terrain inspection. Mineral identification, that's very much in the realm of hyperspectral imaging, and there's fire research as well, that's very much either multispectral or broadband camera for dynamics. So a quick look at the kind of fast cameras here. I have only some listing of the mid-wave series. So we do offer shortwave, mid-wave, and long-wave cameras. I believe today, Joowon will be talking mainly about mid-wave cameras. So we have some of the cameras we offer going from the Fast M3K, which is the fastest mid-wave infrared camera on the market, covering 1.5 to 5.4 microns or 3 to 5.4 if you don't want the extended version. And in full window, 320 by 256 can go to up to 3,100 hertz. But when you shrink down your window, you can allow the flow of data to be minimized in terms of window size, but you increase the frame rate up to 100,000 hertz. So very, very fast camera. And we have basically different types of camera going slower, but that can sometimes offer a bigger, larger spatial resolution with the M1K, M350, which won't necessarily go as fast and won't be as costly, but can offer more spatial information in your scene. The new radio cameras, so we have the M100 and V60, are very interesting. They were just released this year. So we have the M100, which is a cooled camera, but an electroplane cooled system instead of a rotary system like the higher end cameras. It is a 640 by 512 system going up to 100 hertz in that window size. And we have the V60, which is in the long wave part. It is uncooled, an uncooled microbolometer, but we offer the same highly renowned Telops calibration process for this camera as well. So it's a very accurate system and offer a great scientific data quality, even though it's an uncooled microbolometer. So these are great for industrial R&D, university labs, and even DoD tests. Both of these are entry-level cameras, so we're talking about a budget level that's an order of magnitude lower than those other higher-end systems. And not only that, but they're much smaller than those bigger higher-end cameras. So that low swap packaging is great for integration into various systems or tightly packed labs where you have just a small area where you can install the camera. All of these two have a user swappable lens option like all the other cameras, and they all come with permanent radiometric calibration, which is really essential when you have variations in your scene. So you don't need those. You allow that flexibility in that measurement of your scene. All this comes with the Reveal IR software from Telops, so there's no license coming with the software, so you can use that software on as many computers you need, and you can do that data processing within the software itself. It comes with toolboxes as well for the post-processing. So I just want to give a quick intro on what it means doing an IR measurement, what you should expect and look into when you're trying to decide the camera or IR imaging for your system. For train inspection, not everybody does IR imaging. That's the point of today, that we're trying to modernize that train inspection method. So in infrared, it's important to understand the impact of your spectral band. So you can see here in the mid-wave in this region, depending on the temperature of your scene, the peak of intensity of your signal, mid-wave compared to long wave, it's going to change quite a bit. I won't go into the details of the Planck's curve, but it's important to understand that difference in intensity of signal depending on your temperature and your spectral band. So as a great example here, if we're talking about ambient temperature, so at 293 Kelvin, we're talking about a pure, perfect black body in this case, but anything that emits heat, so thermal infrared radiation, would have approximately only 1% of its energy in the mid-wave band compared to 42% in the long-wave band. There's a much stronger signal generated at that temperature in the long-wave band. So depending on what you're trying to observe in your scene, you do have to be considerate in terms of what kind of spectral band or detector you have in your infrared system. So to just take a look at sort of two extremes, if we talk about some very fast high heat generation systems, in this case, some strain-induced heat, where there's a dislocation occurring on a metallic sample. In this case, we're going quite fast, so 43,000 hertz. It's a just stress strain test in the lab, but we're using a mid-wave camera because it's a high sensitivity system with the ability to observe that temperature from room temperature to higher temperatures quite well, and offers a very fast acquisition just as well. So you can do those measurements on samples extremely fast with the mid-wave cameras, and you can go from low spatial resolution extremely fast to high definition, slightly lower speed in this case, but with more information in your image. That's an example of the new contrast enhancement that's part of the software. Doesn't change your data at all, but it offers a visualization tool to understand more what is happening from one pixel to the other within one small region of your scene. Another example of high sensitivity at lower temperature, where we could see that thermoelastic cooling effect within similar kinds of tests. So we have a webinar on that specific topic if you're interested. So going to the other extreme, so a slow measurement, but with extremely high spatial resolution. We have the super HD imaging as well, and the mid-wave series, where we have slower measurements, but extremely high spatial resolution. So these were actual measurements taken by the team of Joowon in South Korea of a few building structures. So great for non-destructive testing, for inspections of the infrastructure in this case, where you need that spatial resolution as much as possible without the need for speed per se. So in terms of requirements for train inspection, it's important to understand a few critical parameters. The main aspect is really the short integration time. We're talking in the range of 100, 150 microseconds to avoid any kind of smearing when you have parts of the train moving by your system quite fast. The frame rate itself, I would say is less critical. I'll let Joowon talk about this a bit more. But from what we understand from people looking to this, if you have at least 100 hertz, it would be good. It's less critical. We're not talking about extremely high speed phenomenon like hypervelocity systems, but it's good to have more frames when you have your parts passing by, of course. You do want a clear image with enough spatial information to understand any kind of change in your scene and the axles that are heating up on your in your train. So typically a mid-range spatial resolution of 640 by 512 is a good way to go for that window size. A smaller window size would smush together more of that spatial information, making it slightly more difficult to understand your scene. It's important to be able to integrate these cameras within those inspection box systems for train inspection. So those fast higher-end cameras all come in a module format to integrate within those systems. And the radio cameras also come in that small form factor that I mentioned. So much smaller cameras, very easy to integrate within inspection boxes. So trains are operating typically outside or tunnels in tunnel environments. So we're not talking extremely high temperature systems. And with those defects or that friction temperature increase, it's important to be able to detect those small temperature increases, variations, and those defects quite well. So that's why for those kinds of inspections, it's good to go for either a fast, if we're talking about Telops cameras, an L200 in the long wave region. M150 is a great option as well in the mid-wave section as well, or the Radii M100, depending on your budget, your spectral needs, and your integration time needs. These are all interesting options for this kind of application. So here we have an example of the M100 where we had a test for a industrial conveyor belt going at about 200 meters, not 200, 2 meters per second. And it was the same idea, the idea to have no smear in this case. So it showed that in this case, a hot glue spot, that's what they were interested in particularly. It's for frame by frame, there's a large displacement from frame to frame, but due to the relatively good integration time for this application specifically, there's no smearing appearing at all. And so we're able to see that movement frame by frame, even though it's going quite fast. Obviously, this is slowed down for the playback. So it's time for me to pass the presentation to Christian. These are some great examples of train inspection images that were done in South Korea with our images. So I'll stop sharing my screen and transfer this to Christian. So here we go. Let me just put you as a presenter. Here you go, Christian. You should be able to share your presentation now. I believe you're still muted. Are you able to unmute yourself? I think you should be okay now.
Yeah, hello everyone, and welcome to today's webinar. My name is Christian, and here is Mr. Kim, our team leader and taking care of the position of a director in this company. So, yeah, thank you for coming here today. So, this webinar is dedicated to introducing TAS-R. It's called the Thermography Auto-Analysis Diagnosis System, Railway, and the solution we have been developing for 10 years. And then today, I'm very happy to introduce about our solutions. Right. Before we start our PPT, we would like to sincerely thank you for coming here, you guys, and as well as to the Telops for making this session possible. Our system is called TAS-R. It's Thermography Auto-Analysis Diagnosis System Railway. This one is the world's first thermal imaging monitoring system for train axle and wheel. So first chapter is about the TAS-R, key features and reliability. Why is the temperature of axle bearings important? The axle bearing failure in railway vehicle is one of leading causes of the alignment. So the main purpose of axle bearing is to allow axle to rotate freely while withstanding the weight of the body. As you can see the picture, here is the wheel, and here is the axle, and here is the tread, and here is the axle bearing. In fact, axle bearing is not moved, it's fixed with the body of the train. But inside there is a called roller bearing. It makes axle to rotate itself and helping them. Over time, the damage accumulated and the roller bearing has damaged. And then the first one is like we can check the heat or noise first, and then the temperature will be changed. After that, that cause the alignments, and nowadays many companies would like to prevent that kind of accident. So we also developed the TAS-R system using thermal imaging camera provided by Telops, and we are very happy to explain about it. Before our system, there are also competitors existing. So previously there were two ways to measure temperature of axle bearing. The first one is hot box detector. The second one is hot wheel detector. However, their problem is that they were not designed to reflect the bogie structure that is connected to the axle bearing. I will share more information about this story later. And to the next, over 6,000 hot box detector systems are installed across the United States, as you can see the map. But there are limitation detection points and structure challenges often result in missed detections. So all of the red dots on the map are where hot box detection is installed. As of 2012, about 160 units have been installed, and so far, more than 6,000 hot box detectors have been installed. The reason for this many installation was to catch errors through more installations, but because of the limitation of sensors function and the structure of the train are different, so it is actually a little bit silly, and I think it was an irresponsible decision. So this both of picture is IR point sensor, and I will explain more about to the next slide. Here is the benefits of thermal imaging. There are two main types of IR detector. One is the quantum type. The other one is thermal type. In general, thermal type has been used a lot because of its low price. However, as a result of various tests, we found that quantum type is more effective for well application. Here is the IR point sensors that I showed you before, and I showed you before. The two of pictures is IR point sensors. Yeah, it has from 1 to 8 points, but 8 points is a little bit expensive. Usually they are using 1 point IR point sensors. But in this case, when you are using IR sensors, it's very vulnerable to contamination. For example, dust or weather or leaves, whatever, everything is affecting to detecting the temperature by using IR point sensors. But by using the quantum type IR camera, it's very easier to manage or maintain. Yeah, also we are using cooled IR camera. The reason why it has a great and high response speed, it means it has an accurate temperature measurement. Accurate temperature measurement is connected to the train speed, and I will tell you about our test and our experiment. Next slide. So we did some experiment to get a little more reliable comparison information. So you can see there is a rotating plate. And please think of the rotating plate in the middle of the screen as a wheels of actual train, and the behind two black body, they have absolute temperature values. So they have a small light in the center, and yeah, after that there is a plate. There is a 10 by 10 milli holes in rotating plate, and during the fast rotation, there are cases where the small light of black body, and at the same time, the small hole of plate coincide in the same positions. So at the time, we could check which has a more reliable test on the temperature accuracy. Here is the cooled IR camera. Here is the uncooled IR camera. In case of cooled IR camera, offer 150 microseconds response time here. And in the contrast, the uncooled IR camera has a slower response time. It's relating to inaccurate temperature readings and blurry images. So now we know the uncooled IR camera has low response time, which means when the speed of object moves fast, the temperature deviates. And uncooled, as the speed continues to increase, the accuracy of temperature decreases. This means that uncooled doesn't catch the difference in speed over time. As you can see, this table, the black body temperature is 50 degrees Celsius. When the object is not moving, the 0 kilometer per hour, it has the same degree Celsius, but in the case of 50 kilometer per hour, it's almost 18 degrees Celsius difference. It's more bigger in the case of 200 degrees Celsius. The black body has 200 degrees Celsius when the 110 kilometer per hour case is 39 degrees Celsius. It's about 170 degrees Celsius difference. So the slow response time of fast moving object makes them unsuitable for price temperature measurement. But when we are using cooled IR camera provided by Telops, we can figure out at 200 degrees Celsius and 110 kilometers per hour, it's almost same. So the fast response time for fast moving object is perfect for precise temperature measurement. So this is the actual images of the three methods. The first one is cooled IR camera, and it has an ROI, and it has a color difference, you can see. But in the case of the uncooled IR camera, it's very blurry because it can't capture in the same time in a speed, whatever. And also, this one is the point sensor that I mentioned before, the two pictures, do you remember? So by using that kind of point sensors, maybe imagine we are using 8 point sensors, but only 3 point sensors can be used, and the other 5 lines will be dead because of the obstacles. The obstacles could be the boogie structure and train structure and contamination from the dust, whatever. So we are focusing on capturing the exact and precise temperature measurements. That's why we are choosing the cold IR camera provided by Telops. Here is the our timeline. We started the development in 2014 and proceeded with the first installation in 2018. And we are complete the Syndrome station in 2022. And lastly, we installed Osan station in 2024. And 2025 in this year, we got a big deal with the Cowell, and 9 sets of our system will be installed in South Korea. As you can see, in the case of existing hot box detector, there's a hot box detector. It's called IR point sensor. It's often installed directly on the railroad or outside like this. However, I mentioned earlier that it is hidden by the structure of the railway and the boogie structure. The boogie structure seems like this one, and the exact picture is here. This one is boogie structure, and the IR point sensor is underneath of the train. We have to check the axle bearing like here, but because of the boogie structure, the laser doesn't work. But to prevent accidents, the United States guys is installing more than before. But that's why we have to think, yeah, we need new solutions, and that solution is task solutions. So this is the chapter 2 about the tasks are data management, etc. This is the core of our technology, and I dare say so. It is the result of our past experience and know-how, and we are going to continue to evolve our system. Here is the system configuration. Yeah, this system is fully automated. First one is entering the train, and we can figure out the train's number by using RFID or camera, and we are capture the temperature by using the cooled IR camera. That information is going to the AI analysis to the local panel, and then going to the data storage, so data server and web server. In the case of number 5, we have already completed development, but we are waiting for release. So previously, diagnosis information was only stored in database, but this upgrade extend to the main database center, allowing user to check test system installed across the countries anytime, anywhere by simply accessing the web and clicking. Let me explain the monitoring software of new web version. As you can see here, there is the 2 axles and there is 3 axles, and we can learn this from we can distinguish by using the proximity sensors. We installed the 2 proximity sensors at the front, which are the first check to train is coming, and the second is to measure the number of axles. In other words, we can figure out the number of axles in each train compartment. And then our camera housing will proceed with the recording, and we image them and then create following menus. So for example, when you're clicking on the train compartment like this, like here, you can check the image file, and if you are clicking, the video also recorded, so you can see the recordings. So as you can see, there is 2 axles image file. So 2 axles, so 4 pictures. So when you are comparing other 3 pictures, one has a higher, so we can figure out it has a problem, or we can send a signal to the web database, and you can get the alarm from your phone or your office computer. So another advantage is that you can prevent accident in advance by checking trends in the heat distribution chart. If you look at the picture, there are 3 pictures and 1 picture is different. What would be problem in this case? As you can see, the no brake taken. This causes all of axle brake to work at once. It's practice, and it's practical one. But once the brake are applied, the following the 4 brakes have to stop at the same time. But its color is very cold, right? So following figures show us the brake doesn't work and look cold. And we also can figure out through the temperature, like a distribution chart. If the temperature relatively low or high, it will deviate from the average temperature distribution like this. And we will be able to use this information to manage important part of the train. And we can control the replace time and repair time. And we can control it and we can chase it. It is the same things. This case is over brake. The first picture, as you can see, there is more red colors comparing with the yellow colors. So everyone has a similar temperature, but it has a higher temperature. So it has a problem we can guess and we can expect. That kind of alarms is going to send to your cell phone or office computer and system. So here is the the most important part is axle bearing and bogie part. We can check the temperature changes in axle bearing and bogie part, and we can continuously manage the track when the maintain is needed and replacement is required. So there is a temperature variation chart. And lastly, we can also can get the alarm like this, and we can check the today's statics, how many trains passed by, and how many alarms we get today. And there is also the device status like a cooler replacement data and washer fluid level, etc. So by using our system is very advanced and high technology, by using the Telops is very thankful. So we would like to preparing exports from last year, and we are finding a new vendor and new distributor all over the world. So maybe it will be very helpful time to you guys, and if you have any interest, I think I can give you an answer. Oh, so lastly, I want to show you our video tapes. Actually, it's in the YouTube channel. All right, thank you for taking your time.
All right, thanks for sharing this. I think the video was lagging a little bit while being shared on the webinar platform. So we'll share the link to the video to the people that registered when we send our thank you email with the presentation. I think that's going to be useful, but we could see the images quite well still.
All right.
Great. Well, thank you very much, Christian and Mr. Kim and all the team at Joowon. Really interesting. I'll mention that Joowon are Telops distributors in South Korea. Just calling them distributors would be a bit reductive, considering all the work that they're doing, the development in the technology sector that they're doing. So I'll invite people to visit the website, seeing what they work on and all the technology that they're involved in. They really have a fantastic drive to foster synergy in the tech sector, really by fostering the communication and the collaborative aspect in the community. So they have a strong focus on environment research and monitoring, automation as a whole, safety and energy sectors. So a lot of interesting work coming from them. So they're really interesting to follow for technology as a whole. So thank you very much for attending, everyone. I'll invite any questions, if you have any, to be written in the question tab. So let me take a look if we have some questions for Telops or Joowon. Let's see. Direct question. So, which model was used for this project? I'm aware that Joowon uses the M150 as a model, but I don't know, Christian, if you can expand on which camera is used for the test in the lab, which cameras are better suited for the field measurements itself. So which camera system is being used? Yeah. Christian, do you want to say something about that?
I'm sorry. What was your question? I'm sorry.
No problem. Which camera model was used for the early test, and which camera is suited for your field measurements with the train?
Okay. The camera.
I don't think it was mentioned on the slides.
Yeah, M150.
So the M was 50. So it was the same in the test and in the field as the M150. Yeah. Okay, great.
Yes.
Other question: how many frames do you acquire per wheel passing by?
180.
180?
Yes.
Okay. So what kind of frame rate are we talking about in that case? It's going quite fast, I imagine.
Yeah, the frame rate is 180 is the same, and the frame rate is of the camera, IR camera.
So about 100 or 150 hertz for the frame rate.
Oh yeah. Oh, we did a windowing.
So, okay, so you did the windowing to get those just the wheel in your window, and then increasing the frame rate a bit.
Yeah.
Okay, great, thank you. Any other question? Okay, so another question, maybe just for me. You mentioned the triggering system for your detection. What kind of response time do you have between your triggering system and the camera? What kind of delay do you have in your trigger?
그 트리거 센서랑 그 딜레이가 얼마나 있는 것 같아요? The trigger has a 1 millisecond. Yeah, one millisecond. I'm sorry, I said it Korean. 1 millisecond, and there is a little bit delay, but it's not affecting the capturing the wheels and temperature and camera shutter speed.
Right. It's just a question of synchronizing with the detection of the movement with the camera. Okay, great. Another question here: does Joowon collaborate with Telops distributors to sell their TADS solution to local agencies? That's I'll let you answer it, but I can say that Joowon is already a Telops distributor in South Korea for the cameras, so they developed the system there as well for train inspection. But I don't know the exact answer for this. Do you collaborate with other distributors to distribute that system, that TADS system, outside of South Korea?
As of now, we are focusing on our installation in South Korea first. And then if we have any chance, we would like to explore and expand our solutions to all over the world.
Right, makes sense. You mentioned you're still in development, especially for the web aspect of monitoring the data. So it makes sense they're still focusing on South Korea implementation.
That's right.
Great. Well, thank you very much. Maybe one last question that came in. Any time frame for that expansion to take place? In terms of the expansion to the rest of the world, do you have any idea how much time Like when you expect that to happen?
Yeah, maybe this year is too tough schedule in South Korea, but we can give our and we can discuss about it in this year, but maybe installation is very hard in this year. So next year is possible, I think.
Okay, that's great. That's really interesting. Okay, last question, then we'll have to stop the webinar. How do the cameras behave in terms of sunlight and reflective surfaces and specular highlights? I'll let you, Christian, mention that for terrain inspection, but I will say, as a general rule, it's important to consider the reflective aspect of the surfaces depending on the emissivity of the material. But when you're in mid-wave, like we have here, it's always a mix of thermal emission and reflective emission. So your environment and the sunlight will impact the radiance that's coming in. So you have to understand your scene quite well to limit the impact of the sunlight. And in case of midwave, the sunlight has not too much of an intense radiation. Like we saw in the Planck's curve, it goes down quite quickly, but it's still, it's still a strong amount of midwave radiation. So you have to understand your baseline in your scene compared to any kind of increased temperature. So at Joowon, I don't know if you did some specific adjustments in your algorithms and your measurements. I don't know, Christian, if you want to talk specifically about that for the inspection of the axial bearings.
If we adding our opinion on your word, first of all, train is very oily, especially the hill and axle bearing. So the sunlight is not reflecting, I think.
Great. Well, thank you very much, everyone. Thank you to Christian. Thank you to CS Kim from Joowon. It's a really interesting webinar, and hopefully we'll see that kind of technology grow even more and be distributed and expanding, not only in South Korea, but all over the world. So thank you very much, and I hope you have a great evening or rest of your day. Have a good day, everyone.